So in number 11, we have the universal set, and then set A is odd numbers. So let's just list odd numbers from these numbers. So we have 3, 5, 7, 9, and 11, because that goes up to 12, the universal set. And then here, prime numbers, we have 2, 3, 5, 7, and 11. So list the members that are in both A and P. So what is in both A and P will be, we have 3, because 3 is in both. We have 5 in both. We have 7 in both, and we have 11 in both. So 3, 5, 7, and 11. Um, and then A or P, the union, basically combining everything. So we have 2, we just list everything here. But of course, you don't repeat elements when you list them. 3, 5, 7, 9, and 11. Is it true that 8 is not a member of A? Yes, of course, 8 cannot be an odd number. So that's yes, because 8 is not an odd number. Okay, number 8. So in number 8, we have a set. The universal set is students in year 12. Now G represents students who study German, and F, students who study French, M, students who study math. Now, then we have this notation here, which means that the intersection of G and M is an empty set. What does it mean? So G represents students who study German, M, students who study math. That means we don't have any students doing both. So we can say that students who study German do not study math. So students who study German do not study math. Okay, so Pretty is a student in year 12. Pretty is not a member of F, which means Pretty does not study French. Use this information to write a statement. So you can just say that's easy one. Pretty does not study French. So Pretty does not study French. And then part C. So we have set A, A and B, A or B, and then we are required to list members of set B. So by inspection, we know that A or B contains members of set B. Yeah. Now we can clearly see that B has to have 2 and 4, so we can write 2 and 4. So we can cross that out. But then we can't have any other number from set A apart from 2 and 4. So you cannot have 6, you cannot have 8, you cannot have 10. So the remaining numbers, um, as you can see here, will just be 1 and 3. And that will be members of set B. And then last question. So basically, the universal set is positive whole numbers less than 13. A is even numbers, and we can list them. So A is 2, 4, 6, 8, 10, and 12. And then B is multiples of 3. So that will be 3, 6, 9, and 12. And then C is prime numbers less than 13. So that will be 2, 3, 5, 7, and 11. So list the members of the set A and B. So these are basically the intersection of these two sets, or what is in both set A and B. Now, by inspection, we can see that 6 and 12 are both in set A and B. So that will be 6 and 12. And then list the members of the set B or C. So that means everything contained in B and C. We'll list everything. So that will be 2, 3, 5, 6, 7. We have 9. We have 11 and 12. And then, is it true that 14 is a member of A? Now, of course, the universal set, what you're considering, goes up to these are positive whole numbers less than 13. 14 is beyond that, so it cannot be in any of these sets. So the answer is no, because the universal set has only numbers less than 13. So the universal set um, has only numbers less than 13.